This is lesson 1.1 out of the Introduction to Algebra book. It's the first lesson in a new book, and it happens to be my favorite book to teach. The first book that we work on, Decimals and Fractions, is largely a review of things you've learned in the 4th and 5th grade, with a little bit more complication added over onto it. But this book, for most 6th graders, is truly new information, new ways of doing math, and I find it to be a lot of fun to teach. So we begin with a very foundational lesson. As I said, we're looking at lesson 1.1, and the title is The 4 Operations. The 4 operations. All right, now, when we talk about the 4 operations, what does that mean? All right, operations are those things that you do to numbers to make outcomes. So the 4 primary operations that you are already familiar with are adding, subtracting, multiplying, and dividing. Now, when you get into more higher levels of math, you'll learn about other operations, but that won't be for a while. The 4 operations we deal with at this level of your math learning are adding, subtracting, and multiplying and dividing. And because students often forget what that word means when I ask you which operation should we use here, students often forget the meaning of operation. What do you mean, what operation? So I'm going to put down here real quick just an add, a subtract, a multiply, and a division symbol, just so we can remember. Operations are those operations. Those are the 4 operations that we'll be talking about as we begin delving into finding the values of expressions. So, as always, we will start with our warm-up. So the warm-up for this lesson is, let's see, number 1. Oh boy, they look really complicated, guys. 6 times 7. Number 2. 56 divided by 8. Number 3. 6.8, 6 and 8 tenths plus 9 and 3 tenths. And number 4, let's see, I'm trying to, that's what it says. Okay, excuse me. Okay, 114 minus 96. So what you should notice here, of course, these are all, very simple, but what they're trying to do is warm up your brain to all 4 of the different operations with whole numbers and decimals. So work those out, and then we will get to our I can statement. So, let's get that up there. Here we go. All right. The I can statement, what we will learn during this lesson is I can find the values of expressions involving, and I'm just going to abbreviate here so we don't have to write it all out, involving addition, subtraction, multiplication, and division. Okay, the 4 operations. I can find values of expressions involving all 4 of these operations. And what we'll be talking about is expressions that have some, several, or even all of those operations in one expression that you then have to find the value of. So you'll see how that looks here shortly. With my dark green pencil, I like to draw a line here signifying that we are done with the warm-up session portion and ready to start into our notes portion. And for that, I'm going to start out with my vocabulary. Just dropped my scissors. Hang on. My vocabulary notes here. Let me cut that out real quick. And it's going to go in the typical upper left position today. to get us started, talk about some vocabulary. Some of it you may be familiar with, but some of it I think is probably going to be new to you. All right, so it's going to go right up here in the upper left corner. Let's get my glue out. Tiny little, tiny tadpoles, as we call them in my class. Just a teeny tiny dot, and then smear it so there's no puddles. That'll soak through the paper. All right, press it, hold it for a second, let it dry, and I'll get my yellow highlighter to highlight the title of our note piece here. This is some vocabulary, and then with my pink highlighter, I'm going to highlight the two pieces of vocabulary we'll be discussing here, and that is numerical expressions and order of operations. Okay, numerical expressions and order of operations. Okay, so numerical expressions, they define numerical expressions as combinations of numbers and operations. So combinations of numbers and these. We talked about what are operations, right? So here's an example of what a numerical expression might look like. 100 plus 3 times 20 minus 15. That is a combination of numbers and operations. I have 100, 3, 20, and 15 for my numbers, and I have an addition symbol, a multiplication symbol, and a subtraction symbol for my operations. It's a combination of the two. Okay. Now, when we get down to order of operations, actually, I'm going to take my green highlighter here and highlight. This is an example of what they're talking about here. And it says down here, good to know, many numerical expressions contain more than one operation. And we've shown that in here as well. So I'm just going to kind of connect these two arrows into these two things on the notes are talking about this example right here. So we'll highlight that up there. Then it goes on to talking about order of operations. What are order of operations? Well, order of operations are the rules to follow when evaluating an expression with more than one operation. You can't simply work left to right. Well, sometimes you could work left to right and get the correct answer if the operations were ordered properly, but you can't always count on that. So there's a set of rules that we use called the order of operations that tells us which operations, which one of these operations we have to process first and then next, in what order. And you'll hear some common acronyms that we'll learn in this that you've probably heard before. But we're going to start out by writing a note here. You can't, oops, I think I'm about to break my lead here. Hold on. Let me get a sharpen on there. You can't work simply left to right is what we're going to write here, since I got a working pencil. And that means I can't simply take 100, add to it 3, then multiply 20, and then subtract 15 from whatever I had there and get the right answer. You can't do that. The order of operations tells us we have to do it in a different order in order to get the correct answer. And I'll give you a demonstration of that in just a second. Sometimes these colored pencils can be tricky to sharpen. Hang on, guys. Just about there, I think. Okay. You can't, let's see. You can't work simply left to right. Okay, write that down, and then we'll show some examples of why that's true. So the note is, you can't simply work left to right. Doesn't work. All right, now with my light green pencil, I'm going to write sort of an explanation for this. if you did, the answer, and we're meaning to this expression right here above, the answer to the above would be the answer to that expression above, believe it or not, would be 2045. And I'm going to write nope. That is wrong. The answer to this expression is not 2045, but that is what you would get if you simply worked left to right. But the order of operations tells us we have to do it in a specific order, and if we worked the order of operations, let's write this. The order of operations make the answer $145. So, if you worked this exact same expression from left to right, you would get the answer 2045. But if you work this expression correctly using the order of operations, the correct answer is 145. How could it be such a big difference? Well, as I teach you how the order of operations works, I think you'll see. And sometimes I have students ask me, well, why? Who decided this order of operations? Why can't I work the problems left to right? And why can't this then be the correct answer? And all I can tell you is that centuries and centuries ago, when mathematicians discovered and worked out how mathematics worked, that's what they came up with. That the order of operations is what makes mathematics work. And so it's one of those things that we just have to learn and accept. It's also one of the reasons why, as you move forward, if you think that you can take a very basic calculator like this, one of these really simple ones that has nothing but the most basic functions on it, and you try to use it to find out what the value of that is, you could very potentially get the wrong answer. It doesn't understand order of operations, and so it would be, using that calculator would be the same as working your expression from left to right. So if the operations in the expression just happen to be in the right order for order of operations, then your calculator is going to work. But if they're not, then it will not. And generally, until we get more experience with working with more sophisticated calculators, sixth graders can't tell the difference. So just know that. Taking out your calculator and working this expression to find the value isn't going to work. It doesn't understand order of operations. All right, so let's take the orange pencil. We've done enough notes now about that part of it, and we'll get back to, okay, what are these order of operations? Okay, what are they? And in what order do they work? All right, so many of you have heard this acronym already, even though you haven't really worked with order of operations yet. But maybe you touched on it a little bit last year. There's this acronym called PEMDAS, and it stands for Please Excuse My Dear Aunt Sally. Many of you have probably already heard that. And we're going to teach with that, but I'm also going to talk about why that's really not the best acronym to use anymore. Some some teachers, some curriculums have come up with other acronyms we're starting to teach, and I'll explain to you why in a minute. But for right now, we're still sticking with PEMDAS because it's the one that kids tend to know and it sticks to them. But along the way, as I said, I'll explain why it isn't really the best way to remember the order of operations anymore, I don't think. But anyway, here we go. So please excuse my dear Aunt Sally. Well, let's see. PEMDAS, please excuse my dear Aunt Sally. I've never known what it is we're supposed to be excusing her for, but here we go. Please excuse. So please excuse my dear, oops, oh. This is where my erasable pen really comes in handy. Some of you know I started out using a regular pencil on these videos, but graphite has such a shine to it that it would be really hard to read. But this erasable pen I found does a pretty darn good job. Okay, so A-U-N-T, there we go. Please excuse my dear Aunt Sally. All right, so this helps us to remember the order of operations because when we are trying to find the value of an expression with multiple operations in it, there's a particular order we have to solve it with. And that particular order is first, the P stands for parentheses. P-A-R-N-the-Cs. There we go. Parentheses. All right. Now, this is the first area, really, where this acronym kind of goes wrong, because we say the first step in order of operations is parentheses, but really the first step is grouping symbols. And grouping symbols include parentheses, but they also include brackets, and you'll learn during this block that it also includes a fraction bar. A fraction bar is a grouping symbol. That's probably hard for you to imagine right now, but as we move forward, you'll be able to see how that is. So at this point, when we say first we deal with parentheses, remember really we mean first we deal with grouping symbols. And you'll hear me say that probably more often. Where are our grouping symbols? But this is just where it started with this acronym, and this is a prime reason why people are, teachers and students are starting to move away from this acronym. But as long as you know that the P stands for parentheses, which really means grouping symbols, will be okay. Well, I'm going to use my light blue pencil and put a 1 right here. Step 1 for order of operations. Now, step 2, the E stands for exponents. And in tomorrow's lessons, we'll learn how to deal with solving exponents and what they are. All right. So, exponents. Exponents is the second step in the order of operations. So with my orange pencil, I'll put a little 2 next to that. Now, this one changes things a little bit different because it looks like there's 6 steps in the order of operations, but there's really 4, because multiplying and dividing, which is what M and D stand for, are handled at the same time from left to right. And these are the things that we'll be working on in this lesson. Multiply, whoops, come on pencil. Multiply is what the M stands for. Divide is what the D stands for. And we do those together from left to right. All right, and then, let's see, and so I will take my brown pencil and put a 3 right next to those 2. That's step 3 in our order of operations. All right, and then the final step in our order of operations is adding and subtracting. So I'm going to write add, the A stands for add, and subtract. The S stands for subtract. Oops, Tried to make that a K. All right, add and subtract. And then with my, where did it go? Oh, yeah, light green pencil still, huh? Light green pencil, oh, that's dark. Light green pencil, 4 in a circle, add and subtract is our fourth step. All right, so these are the order of operations. First, we deal with grouping symbols, which includes parentheses. Then we solve any exponents we have in the expression. Then we do any multiplying and dividing, working from left to right. And then we do any adding and subtracting, again, working from left to right. All right, so we're going to write a little note over in this corner down here, and it's going to say, it may seem a little backwards dot dot dot. It may seem a little backwards, but we'll start with steps 3 and 4 while learning order of operations. So what this means, guys, is when we work on an expression like this, we would solve it in this order. But you'll notice in this expression I wrote, we don't have any grouping symbols, we don't have any exponents, because we need to teach how to deal with those. They're a little bit more complicated than these operations you're already familiar with. So we'll handle that later. We're going to start instead with expressions that simply deal with multiplying and dividing and adding and subtracting. So that's what I mean here by it may seem a little backwards when I'm telling you this is the order of operations, but we're going to teach you how to deal with expressions that only have step 3 and 4 in them first. All right, so that is the end of our first page. Now we're going to go into the second page of notes showing how we actually work out these orders of operations. Okay, so now on our second page, we're going to start with the other little notes sheet you have that says order of operations at the top, and we'll put it right up here in the upper left and talk about the actual steps that we'll be working on in this lesson. All right. I'm going to put this way over to the side so I got plenty of room to write off to the right. Okay, so order of operations, highlight that with my yellow. And these are the 2 steps that we are working on in our order of operations today. We are working on, where's my problem? Okay, so this says step 1. But I don't want you to get the idea that that's step 1 in order of operations. It's not. It's step 1 for what we're working on today. So let's cross that out and with our brown pencil, put a 3. Because in the order of operations, it's the 3rd step. And it's just that, as I explained later, we're working on steps 3 and 4 in this lesson. All right, and so then with my light green pencil, I'm going to cross out that 2. And put a 4 in a circle. Those are the ones that we are working on today. All right. And then below here, I'm going to write my little acronym, PEMDAS, P-E-M-D-A-N-S, right? And then remind myself that multiplying and dividing are handled right here. It says here that's what they called step 1 is multiply and divide from left to right. All right. And then they say add and subtract from left to right. That's these right here, these steps here. Add and subtract from left to right. So I'm going to highlight that. Oh, I think I'll just use my pink one here. Multiply and divide happens before we do any adding and subtracting. Okay? All right. So that's how that should look. Okay, but this is just to show you that this is the area of PEMDAS, the order of operations that we are working on in this lesson. Okay, so I'm going to take, let's see, I think it's a blue pencil here, and I'm going to write a note out here so that later when you're referring, you'll know what I'm talking about. All right, even though the order of operations appear to have 6 steps, meaning PEMDAS, we work them as 4 steps. And we've already talked about that. I just wanted to get that note into your notes so that later when you're looking back at this and wondering, why is this looking quite the way it is? So then, with my brown pencil right underneath here, I'm going to put a 3. This is my 3rd step in PEMDAS, and I'm going to write, again, so that later when we're looking and we need reminders, the M and D are multiply and divide. 1 step at a time. 1 step at a time. And I'll explain that in a minute. Just write that note. The M and D are multiply and divide 1 step at a time. All right. Then with my light green over here, I'm going to put my 4 in a circle. We'll talk about that step 4. And we will write how the A and the S are add, I don't want that, hold on, add and subtract, again, 1 step at a time. 1 step at a time. And I'm going to take my red pencil. This is such an important thing we will be talking about here. 1 step at a time. I'm going to underline that. 1 step at a time. And then with my blue, I will write left to right. So 1 step at a time, working left to right. All right. Now this might not make sense to you right now, but in just a minute it is. I'm going to show you how it works. All right. 1 step at a time from left to right. We'll create something kind of magical called the Pemdas Triangle. And you'll see what I mean in just a minute. All right. Sip of coffee there, and we'll dive right into it. Okay. So those are the notes that go along with this. I'm going to underline that with my orange, so that we can get right into the examples now, and you'll see how all of this stuff we've been writing about and talking about actually works. Okay? All right, so here's an expression. 3 times 4 plus 10 divided by 2. All right? Okay, now we're dealing only with multiplying, addition, and division here in this expression. Now, our order of operations says that I have to do multiplying and dividing before I can do any adding and subtracting. And when I look at my multiplying and dividing, I have to work from left to right, one step at a time. So working from left to right, I look for my very first operation, and it is a multiplication operation. Multiplication comes before add, so I have to do this one first. So that means I have to work out what is involved in this particular operation of multiplying. 3 times 4. Well, 3 times 4 is 12. So I'll write that 12 right underneath there. And then before I do anything else, I bring down the rest of the expression. That means copy down next to it the rest of the expression, just like that. Now, I have to reevaluate what I have left. I have to do any multiplying and dividing before I can do adding and subtracting, working left to right. So working left to right, I come to the first operation, that's addition. I can't do this one because I can see my next one is a division operation, and division must happen before any adding or subtracting. So I have to work out this division operation, which is 10 divided by 2. That is 5, so I write that down there. Working one step at a time means then, before I do anything else, I bring down the rest of the expression. Now the only operation I have left is an addition one, so 12 plus 5 is 17. I'll just put that down there. Here we go. 12 plus 5 is 17. And I'm going to circle my final answer with my red pencil. Now here's where I'm talking about with the Pemdas Triangle. If you have done this correctly, one operation at a time, then your expressions will form this triangle, which I want you to create with your red pencil like that. That shows me I have done this expression as my instructions are, one operation at a time. If you try to do too many at a time, if I try to do like this one and this one at the same time, I wouldn't get this triangle, and I'm more likely to make a mistake. Later, when you're more sophisticated students and your problems get much more difficult, you may work into being able to do that. But right now, all of us 6th grade teachers will be very strict about one operation per line, carry the rest down. That creates your Pemdas triangle. All right, so let's do another one. This one is going to be 40 minus 8 times 3 plus 6 times 5. All right, looks like a pretty long operation there, but it's the same thing, one operation at a time, according to our PEMDAS rules. So working left to right, I see my first operation is a subtraction symbol, but I also see that I have multiplication symbols in my expression, and I have to do multiplication before I can do any addition or subtraction. So that means I have to move over to this very first, working left to right. I can't do this one first because I have to do the multiplications left to right. So I have to do this one first. So 8 times 3 is 24. I write that down, and then I bring down the rest of the expression I haven't dealt with yet, one operation at a time. So that makes it look like this. So then I look across. I see I have a subtraction and I have an addition, but I still have this multiplication in there. And that multiplication has to be resolved before I can do any addition or subtraction. So 6 times 5 is 30. I'm going to write that down. And then bring down the rest of the expression I haven't yet dealt with. Now I can look and see that the only thing I have left is addition and subtraction, and that's the final step in PEMDAS. But I have to remember I have to work left to right. I can't do this 24 plus 30 first. I must work left to right. So 40 minus 24 is 16. Bring down the rest of the expression. And then I'm left with 16 plus 30, which is 46, and that's the final answer to my expression. So I will circle that in red, and make my Pemdas triangle. And it works out perfectly. All right, beginning to see how this works? I hope so. Okay, here we go. Let's do one more. All right, over here. Let's see, am I in frame? Yes, okay, good. All right, over here, let's do 4 times 3 plus 5 times 2 minus 3 times 3. All right, we're working left to right. We have to find any multiplication or division operations first. My very first operation is a multiplication, so I know I need to do that one first. 4 times 3 is 12. I write that down, and then I bring down the rest of the expression. Plus 5 minus 2 minus 3 times 3. All right, I'm still looking to see if I have any multiplication or division. Can't do that because I see I have this one right here. So 5 times 2 is 10. Bring down the rest of the expression. Do I have any more multiplication or division? Yes, I do. The first one, last one, is right here. 3 times 3 is 9. Bring down the rest of the expression. All right, now working left to right, the only operations I have left are addition and subtraction, so I will work those working left to right. So 12 plus 10 is 22. Bring down the rest of the expression. And then 22 minus 9 is 13. And that is my final answer. So 13 is my final answer. I'm going to draw my Pemdas triangle here. All right, see how that works? Okay, so let's make a couple of notes right in here about what we did here, so later we'll remember. With my green, I'm going to write in capital letters 1 operation at a time. 1 operation at a time is an absolute must. And I'll put this around here, and I'm going to draw a little arrow to what I'm going to put over there, because with my blue I'm going to write the Pemdas triangle. When you do things 1 operation at a time, like I said here, then you wind up with the Pemdas triangle that you see we did here. All right, is that all fitting in there? Right, okay. That's how order of operations works for step 3 and step 4 in the Pemdas scheme of things. That's how you would work the multiplication and division first, and the adding and subtracting next. Okay, so let's take a look at our practice problems for lesson 1.1. Problem number, I'm not sure that's focused very well. Hang on, guys. Okay. Problem number 1 is 15 minus 10 divided by 5. Remember, 1 operation at a time. Number 2 is 6 times 10 plus 22 divided by 2. Number 3 is 2 divided by 2 plus 8 minus 3. And the last one is a word problem. It reads, 3 friends went out to eat. Their bus ticket cost $1 each. Their food cost a total of $20, and each left a $1.50 tip. What was the total cost for the evening? All right, so you might want to pause here. I'll show you again the first 3. And then the last one. Okay, so I'll show you how we work these problems. Okay, so problem number 1. I have to work left to right, multiplying and dividing first. So as I look at this, I see that I can't do anything with this subtraction, but I can with this division. So 10 divided by 5 is 2. Bring down the rest. 15 minus 2 is 13, and that's my answer. So I would circle that 13, and here's my Pemdas triangle. One operation at a time. Okay? All right. Number 2. As I look across, I see I have to look for multiplication and division first, left to right, and I have a multiplication right off the top there, okay? So that 6 times 10 is going to be 60, and I bring down the rest. Then I look again. Do I have any more multiplication and division? Well, I can't do this addition yet. That has to happen after I've taken care of all multiplication and division. I have a division right here. 22 divided by 2 is 11. So I'll write that down and bring down the rest. Now I'm left with just one operation of 60 plus 11, and that is 71. And so that's my answer. I'll circle it. And Pemdas triangle. Yay. All right. Okay, number 3. Left to right, as I look, I have to look for multiplication and division first. And I've got a division right off the bat here. So 2 divided by 2 is 1. Bring down the rest. Now all I have left is addition and subtraction. There are no more multiplication and division. So I can work left to right. 1 plus 8 is 9. Bring down the rest. 9 minus 3 is 6. And so there's my answer. I'll circle that. And there's my Pemdas triangle. All right. Okay, so the last one is 3 friends went out to eat. Their bus ticket costs $1 each. Their food cost a total of $20. Each left a $1.50 tip. What was the total for their evening? All right, so I need to work out this, what is the expression going to be? I'm going to do it in the space up here. There's not enough room below it, all right? So I'm just going to work one piece at a time. Where there were 3 friends, and their bus ticket costs $1 each, right? So if the bus ticket costs $1, oops, and there were 3 of them, then that's 1 times 3. Okay. All right. Now, their food costs a total of $20. So to this we can add $20. That's how much it costs total for them. They each left a $1.50 tip. So that's we're going to add to this $1.50. Oops. Let's not put that. We'll just put 1.5. Okay. I better erase that. We don't need the 0 on the end, right? We can put it back when we put it in a money form, right? So $1.50, they each left $1.50. So how many friends were there? There were 3. So that's $1.50 times 3. Okay. So now, what was the total of their evening? We've got to use our order of operations that we've been learning to solve this. So first we look for multiplication and division left to right. 1 times 3 is 3. Bring down the rest. Okay. Any other multiplication or division? Yes, right here. 1.5, I should say that right. 1 5/10 times 3 is 4 5/10. Then bring down the rest. Okay. Now working left to right, do I have any more multiplication or division? No, I don't. All I have is addition. So I've got to do that working left to right. 3 plus 20 is 23 plus 4 5/10. And now 23 plus 4 5/10 is 27 5/10. But we're dealing with money, so we're going to add a 0 here and a $sign there. And that's our answer. Okay, that's not really our answer. Why? Because what's our next step? Okay, That's how we got, because of that labeling I put in here, we don't quite have the triangle that's nice and neat. But what I have to do is write an answer down here, correct? So the answer is, what was the total cost of the evening? The total cost was, that's supposed to be 27. Why did I write 25? Sorry about that. Sometimes talking and writing at the same time doesn't go really well for me. You guys who are in my class, you know that. All right, here we go. $27.50. That's the answer to that word problem, circled in red. All right? Okay? That's how that works. All right, so that's our practice problems for lesson 1.1. Let's take a peek at the worksheet for lesson 1.1. Pretty straightforward, guys. These are all just problems exactly like we did in our notes. And you should be able to do them right on this paper if you write small and get your triangles. I'm going to give, and just make sure that your answers, that your work that you show, looks like this. It's got to be one step at a time. If you do it one step at a time, you'll get the Pemdas Triangle. If you try and do too many steps all at once, you won't, and your chances of making mistakes are much higher. So one operation at a time. And when I did the key writing small, I had room to do it under each one of these right on the worksheet. So nothing really tricky about these if you're following your notes. They're all very much like it. Now, this bottom section here is going to really require you to work your brain. It says insert one of the four operations, addition, subtraction, multiplication, and division, in each box so that the numerical expression equals the stated amount. So you're going to have to do a little bit of trial and error. But you're going to have to figure out which operation do I have to put here and here in order for this to equal 26. Okay? Same thing with these. In order for this to equal 10, should I put an addition or a subtraction or a multiplication or division symbol here and here? Okay, which ones? And I'm going to tell you, because after you work on it for a while and you're not hitting the right combination, you'll think this must be a mistake. This doesn't equal 26 or whatever. I get that every year. It's not a mistake. All three of these, if you put the right operation in to the right spot, will equal the stated amount here. So you're going to have to play with it, and this is where you use your grit. Keep with it. You'll find the right operation. All right, that's the lesson. Last is exit ticket for lesson 1.1. Oh, I hate the, I'm trying, here, let me just do this. Trying to get it out of the glare there. Okay, and I'll try to zoom in on that for you a little bit. All right, so this is just for if you want some extra practice. I don't give you the answers to this, and your teacher may use it in some other way. You might want to work this out on a separate sheet of paper if you're looking for the extra practice. Okay, so that's lesson 1.1 of Intro to Algebra. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.